All right, hello, Cheerskevin here, and welcome back to AstroBlock. And I feel bad that because of the corrupted audio in the last video, we didn't get to mess around with RFTools Control. So we're going to address that in this episode. But first, I put together the stuff that we talked about at the end of the last episode, where whereby we craft ourselves up some Phytogrow. Now, if you remember, Phytogrow required niter and pulverized charcoal and something else. What are we even producing? I don't remember. Let's walk through this. So, we have a pulverizer that takes sandstone. Well, we have sand coming in that gets constructed into sandstone. The sandstone comes in and produces. Oh, right. It produces. That produces niter. Then we also need. Then we put in some. In here, we're induction smelting some cobblestone and sand, and that produces. We don't care. Stone bricks, we don't care. But it also produces slag as a byproduct. And so the slag comes out of here. The the niter comes out of here, and then back here we have a lovely little tree. Putting stuff into an electric furnace, giving us some coal that gets pulverized and thrown into here. So we have pulverized charcoal, niter, and slag producing Phytogrow, which can be piped into the phytogenic insulator, which will go ahead and craft us up potatoes, which we can then pipe into a redstone furnace, and we have baked potatoes. Now, this is not hooked up to our AE system as yet, but we have this lovely compact machine that will just produce endless baked potatoes for us. So that's pretty nice. And it actually brings me to the subject of another thing that I want to be able to do using RFTools Control. And I've mentioned this in the past. We want to have a to-go bag, basically, and we want to make sure that it always has our anti-radiation medicine in it, and it always has food in it, right? Because those are things that we're going to need. Actually, speaking of, we should actually grab some potatoes. So let's go ahead and grab that. Now, you may notice I've had less time kind of between episodes to respond to comments and things of late. I'm actually going out of town, and I think this is probably the last episode across all of the series that I'm going to get done before I leave. So it's been chunking up a couple of things. We'll see how that goes. Okay, but yeah, we want to create a new RFTools Control program because we're going to need. Let's see, we have the ender chests. So there we go. There's an ender chest. And you can also make the ender pouch. And I don't know if we have the ingredients. Yes, we have the ingredients for that. Cool. So we have an ender pouch. Let's grab, what sort of dyes do we have? We have light blue dye. We have, we have cyan dye. Let's use cyan dye. Let's put some stuff away as well. Because I'm just bad about that generally. And let's plop this down as something that, just we're going to prove a concept of this out here, and then I'll eventually get it constructed fully, and we'll throw it somewhere on the factory floor, and it'll be great. If we go ahead and, how do we dye this now? Oh, that's interesting that it actually opens up that same thing. That's neat. Okay, cool. But okay, so you have to shift right click a correctly colored chest. Let's go ahead and just cyan dye all three, and then we'll do that. Okay, now we see these two are linked, and they're not the main thing that gets imported into our system, so we don't have to worry about that again. All right, I like that. So the idea then is that I want to be able to, at any point in time, be able to open up this ender pouch, and I want the top to be stocked full with potatoes, or maybe we want anti-rads. I don't know. I want the middle row to be full of potatoes, and I want to be able to shift-click anything into here, and anything that is not those materials, it should automatically extract them for me. Actually, thinking about that, we should probably tell it to leave the top row open. That way, when we do shift-click, it's going to put them in the top, right? Because otherwise, we'd have to worry about, if I pull out some potatoes and before I can replenish and I put some stuff in, then it's going to assume there are potatoes, and that's, So easier is we'll just say, hey, I want this to be full of anti-rads, and then I want potatoes down here. So then at any point in time when we're out and about on assorted planets and whatever, we can open up our ender pouch, get the food, throw away some inventory that we know we're not going to need, and that'll be wonderful. But that's going to necessitate putting specific things in specific places. So that's a good case for RFTools Control. So let's go ahead and grab the programmer out of here. We've got that, and we actually have a program card, because I had one from before. Let's see, we're going to need the processor. Do we have one, though? I don't think that we do. I just typed it again, because I'm an idiot. There we go. Okay, nope. Need a machine frame, which, cool, we've got that. And then we need card bases. Oh, nice. Okay, cool. Got nervous there. Okay, so the processor will go there. And the assumption is that we will eventually have an interface up here whose job it is to keep stocked with materials, but for now, I guess we'll just put a regular chest up there. We'll go ahead and craft that up. And we'll plop our programmer down so we can actually write the program here. And we're going to need to power this as well. Let me grab a... Okay, so let's go ahead and clear this program. I suppose we can put this in the slot, but it doesn't necessarily matter. And now we have to decide what is the thing that we want to trigger this event. And I think for now, let's tell it, well, yeah, we'll have this start on redstone. Now, let's just start. We'll do this, yeah, well... Okay, yes, on a redstone signal on. What do we want to do? Well, we've got two things that we need to do. We need to check up and we need to check down. We need to, well, okay, let's take it easy for a second. I want to reverse the direction of these. I mean, it's an aesthetic decision, but I think it's a little cleaner. Because this will eventually be, because, then we won't have a chest that opens up for no reason. There we go. Although, actually, if we plop a chest under there, a vanilla chest, it won't open. So a chest is not going to work. Okay, formation core and interface. Not that recipe, this recipe. Thank you. Interface. Okay, and this is going to exist in block form. If we put it here, can it... it's going to take things off our network? No, those are online. Cool. And this seems to be probably online, too. And if I tell it, hey, I would like you to keep an iron in here, will it do that? Let's make sure we put it in this way. Yes, it will do that. Okay, cool. So this is on the network. It's already working just great. Just swell. And that means if we push stuff into it, it should go ahead and automatically import stuff into the network, which is great. Okay, let me rearrange this then. We'll set up we'll prototype while on the AE network, and that'll be nice. Okay, so this is how this thing will be set up, and I think let's pick out some alternative items right now, since right now potatoes and neither potatoes nor anti-rads are being produced and thrown into the network, so we'll use some stand-in materials. Let's say that diamonds are stand-in for potatoes, and then lapis are stand-in for anti-rads. What we will tell this is that, hey, I would like you to store a stack of diamonds in this interface at all times. And actually, I'm just going to go ahead and use anti-rads, and I'll put that there. And of course, if it had something in it, yeah, okay, there we go. Now it can. Let me also specify the priority on here. As being 5,000, so that this thing has priority. And the reason I want to use the anti-rads is because they won't stack, and that is important. Okay, so on redstone, no, every couple seconds. I don't know if it's easier to debug if we do on redstone, but the ultimate thing is going to be every couple seconds, every 20 ticks or whatever. Yeah, we'll go ahead and clear the program. So repeat every 20 ticks. We need to tell it, yeah, constant. Every 20 ticks, and make sure that this can only run one at a time, please. So if it's still in the middle of running from 20 ticks ago, then go ahead and don't run the next one. What we want to do is we want to check, I guess, first off to see if there's anything in these first slots, and if so, push them into this interface, right? Yeah, so basically push them from up to down. So let's put some stuff in those slots just to make sure that it's able to clear those out so that our test case will run. So this should be, I think this is going to be slot 0, 3, 4, 5, 6, 7, 8. So from 0 to 8, we want to pull those items and push them down. So we're going to want to look at loops. There are categories here. That's graphics, numbers, energy. Okay, so here we go. Test loop. Loop a variable until it reaches a specific value. Make sure to set the variable to the starting value of the loop before this opcode. Cool. The red output of this opcode is executed when the loop ends. Okay, interesting. So let's drag this on, and it's not going to be the first thing because we need to set a variable first. Oh, there we go. Category numbers. Eval number. What is this going to do? Evaluate a number and set it as the result for future opcodes to use. Okay. Okay, here we go. The set variable, and I don't know if we can set variable directly or if we need, no. Okay, so we can't just set a variable to a thing. We need to set a variable via evaluating. So we need to eval a number, and that will just set a number. So let's say we're starting at 0, assuming, and then we're going to say, hey, store that in our own variable slot number 1. Okay? Then from there, we're going to look at the variable in slot number 1, and we're going to end. Let's see, what's this going to do? Let's double check here. Let's see. It is going to loop a variable until it reaches a specific value. Is this going to increment it? I don't think so. Oh, first var is 0. Okay, fair enough. So let's not store this into slot 1. Let's store this into slot 0. The first variable is 0, and here first variable is 0. And we may need to end up dragging these things up, I think. So there are going to be 2 exits from here. The red path is what happens when this loop is done, when the thing is no longer up to snuff. It says it's inclusive, so we're going from 0 to 8. Is that right? We'll put something in here and we can double check that. Let's see. 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so 0 to 8. So we want to say a loop until the value is 8, and it does say it's inclusive, so it should run that when the value is 8. Or I suppose maybe not. Depends on how you interpret inclusive. So okay, assuming that this value is within that range, so it's still less than 8. Actually, well, if that's the case, then why wouldn't we just use a less than? Yeah, so I don't think that is. I think this may actually increment for us, which would be nice. So let's there's a logging statement that we can use to print the value out, and then we can just run this. Yeah, log messages to processor console, and yeah, just log variable 0, please. And this will be the happy path. Cool. And then here, when this is done, let's tell it to log done. There we go. Okay, let's go ahead and save this. Oh, sure, debug works as the name. Save it, and we'll grab this program out, throw it into this CPU, which we have not put the flux point back down yet, so we've got to make sure to do that. And I do think as well that we need to allocate. We're going to need to allocate space here. Well, maybe. Oh, you know what? This also needs needs something. If we look at the one that currently runs, it needs a CPU core, which needs to be used to allow it to run programs. So we need to craft a CPU core for this thing. Okay, so card base and a CPU core. And now this processor should be able to run. Where did that just... No, okay, that just put it in there. There we go. Okay, now it is saying that it is missing the variable. Yeah, we might not have the ability to even use variables without throwing RAM in the system. So let's see. RAM chip. So we need a card base. And then RAM chip. Cool. Let's throw that in here as well. And then hopefully... Okay, there we go. Now we actually have variable slots. So cool for us. Variable is not defined. Yeah, fair. Let's just say you are allowed. Let's see. Can I say you can use this? Okay, there we go. Okay, so that counts from 0 to 8 and says done. Okay, so it does do what we expected it to do. We just needed to put RAM in there. We don't need to assign this yet. Oh, cool. Let's go ahead and pull this out, please. Go ahead, stop. And there we go. So let's put this in. It does what we expected it to do. Hooray. So from 0 to 8, we're going to want to basically move anything. We don't even care if there is something. So if it fails, we don't care. We'll find out. I don't know if we have to handle the error case or we can just kind of ignore it. But okay, so this is then the happy path. So I guess we can shift this up here. It doesn't hugely matter. So this is for the first 8 slots, we want to look at the inventory above us and move anything there into the inventory below us. So we're looking at, I think there's a category for items, right? And we will just say fetch items, and we'll just override here. Okay, I got to get rid of you. We'll fetch items from the inventory that is above us. And we don't care. You can specify what side you're accessing from. So like if you're pushing into a furnace from the side versus from the top, it matters, but we don't care in this case. So we're pulling from the top, and the slot needs to be whatever is in variable number 0. And we don't care about the item. We're not going to tell it. The amount, we're not going to tell it either. It will fetch the stack if it's not given. The slot out is where in our own internal place we put stuff. So we're going to tell it slot, our own internal inventory slot 0. And then routable, we don't care. That's not relevant to our interest. If we take this and assign, so there we go. Now we have this is our own inventory slot where it can put items temporarily. We can't pull items from adjacent to us and push them adjacent. We need to do that in 2 steps. So we're going to grab stuff from the ender chest, put it in our internal inventory, and then push the items out. Okay, so let's say push items right there. Then we're going to do the same thing. We do need these now because we need to be able to route back to the loop. Actually, we can just do this way, and then just get rid of this connector, put this way, and then this way, which is, so we're basically, the loop is going to go this way. Okay. I have misunderstood exactly how this works. So this is a little weird. This doesn't set up like a branching path. It will only run, So it will run this, and then it will immediately jump back to the loop. So you can only run one operation, which isn't particularly helpful for us. That's annoying. Okay. So we pretty much can't use loop. Let's get rid of loop, because we need a loop that does multiple things. It needs to try and fetch items and push items, and we can't just fetch all the, well, I suppose we could. Yeah, in theory, maybe we just do that. We fetch all of the items, rather than use one slot. I thought we would use one slot, but okay, we can make this work. Okay, what a mess. Okay, so in variable 0 up through 8, fetch it. So fetch the items, and then we basically need to do a whole nother loop. I guess that means we don't need any sort of feedback into the loop, so we can just go ahead and scoot these up. We'll need another loop down here, and basically this becomes the path once we're done. So we loop over all 8, and then we'll have to do the same thing, although I guess we'll, scoot these out of the way for the moment. So fetch items is now not going to be, yes, it is in slot V0, slot out, so our internal processor slot also needs to be slot V0. So, yeah, that's going to be interesting. And let's have it just do that for now, and this will print out done. No, this is your happy path. No, this, you don't have a connector. This is your done path. This is your looping path. Yeah, so basically it's a one-step loop, and that's all. And just to make sure, if we allocate, yeah, okay, so we can give this thing 8 full slots to work with. It's just, yeah, or sorry, 9 full slots, I suppose. Cool. So now from 0 to 8, so for 9 times, it's going to pull stuff and put it in its own inventory, and then it's going to say that it's done. That should do it. Okay, I was holding shift, so whatever, that's fine. Let's put another thing up here, and this should at least pull things into its internal inventory. It's not going to push things out, though. Yes. Okay. So it grabbed those slots, and then it said done, and it didn't grab more, which is what we want. Okay, cool. So that's good. Let's go ahead and we can move on to the next step, and that is pushing the things into the interface. So I should be able to copy this and paste this. So move the done here. Let's paste this there, and we need to, yeah, just get 0. Is there like an easy way for me to just clear a variable, because 0 being, kind of a default? Probably not. So we'll take this, paste it there. Of course, it needs to output down. So we're saying, okay, now take 0, store that into slot X, and then, yeah, this is going to be kind of messy, but that's okay. We'll make it work. Then we need another loop, and this is going to be, well, actually, it's going to be the same loop. So let's just get rid of this. We'll just select you, copy you, and paste you. And that should be the same. So while this is in var 0 up until 8, go ahead and push them downwardly, and we'll see if that works. And then when you're done, say done. Okay, so this is the process right now. So we've not tested this without items in here, so we've not tested failure cases, but we'll see. Okay, it pulls in those, and now it is pushing them, and it says done. Okay, but it pushed one of them, so that's something. Right, okay. Yeah, we did not update this. We need to change the slot in to be whatever is in variable 0. Yeah, because it was basically just trying to push the same thing multiple times. Oh, no card. Yep, there you go, have a card. And there we go, it pushes those on the interface. Okay, cool. So we now have a thing that every second will try and pull things out of here and break for some reason. Nope, okay, it worked. It was just a little slow. It will pull things out of this top slot and throw them into the interface, and the interface should import them into the system. Hooray for that. That's a start. All right, so I'm going to be a little inefficient here for the moment. I'm just going to wire these like this, which is like this. I'm gonna bring us all the way back to the left just to make things a little more readable, hopefully for me. We'll find out. Because now this loop is not going to work for us. We're going to need something a little more permanent, because we can't just combine things into a single step now. Let's first off test. Let's test the indices of this interface. So let's try something. Let's just fetch an item from down and push it up, and see if that works. So let's fetch item from the inventory below us, and we'll say from slot in the inventory, let's say slot 0. I'm assuming that that's we're going to refer to the diamond. We'll tell it just to pull one of them. And we'll find out if that's correct or not. Well, sorry, we're not going to tell it which item. We're just going to tell it how many. So the amount 1, and put it into our internal slot 0. And yeah, well that's all. That's all for now. Okay, so that's correct. So it did pull up 1 diamond. Hooray for it. And of course now it is pushing it down again because the program is a little fun that way. But okay, so that should work. So then what we need to do is we need to loop over. We need to check our upward inventory and then do things based on whether or not it needs stuff. Right? All right. So we're going to say number is going to be 9 because we're looking now at the at this middle slot, which is going to be where we want to fill potatoes. So we say 9 and then store that into variable slot. Variable slot. Slot 0, which is just our looper. Okay. So then we want to compare that. We need another eval number, and this eval number is going to be the beginning of our loop process. So I'm actually, let's see, we're gonna we've got to put this is getting clumsy, but okay, we're gonna put this down here and put it out to here because we need to loop back into here to start our. We need to route back to here to start our loop because we need to say, okay, the ending number is going to be. Actually, can we do a value? Let's see. Yeah, we can't do, hey, our 2 variables equivalent. We have to look at only one thing at a time or the output of the last opcode, which is okay. Okay, so 17. Oops, I hit my numpad. 17 is the last value that we want to look for that middle slot. So we're going to say evaluate 17, and then we're going to do a compare. Let's see, is that greater than variable? We want it greater than or equal to the variable, don't we? This is going to compare whether that value is greater than. So now I think it's exclusive. So actually, I think we want this to be 18. I could be wrong. We'll find out. Okay, so if it is, then we can continue. So if this number is greater than what we have in the slot, then hooray, we can go ahead and continue. Otherwise, yeah, otherwise our variable has incremented and we are done. Okay, so we're assuming that we're done. Whew, this is, yeah, it's weird to think about things in this way. I mean, it's fun though. So then just to think about how this is going to have to go, we're going to have to increment the variable. So we're going to have to add the number and then store the number to a variable. Oh, you know what? Yeah, we can just route back to the incrementer. Yeah. I like that. Okay. So in any situation, we can route back to here. So, well, yeah, the loop back is going to go like this. So we're going to store, regardless of where things come from, we're going to store them into our variable. Yeah. Okay. So then this goes like this. And let's do another log message just as our test case. Yeah, an add number is going to be nice and easy. It's just going to be looking at variable 0 and a value of 1. So adding 1, and we just need a wire here. And this goes to there. Cool. I think that's right. And then here, let's just output the value of variable 0. And that should be a valid-ish program, maybe. Oh yeah, we're missing some values here. Okay. Greater than variable 0. Cool. Let's see what the heck happens here. Let's clear this. So again, it's going through, it's a little slow. Okay, 9, 10, 11, 12, 13, 14, 15, 16, 17, done. Okay, cool. I like it. So this is effectively the same as this individual loop instruction. It just allows us to now chain multiple operations with that variable being a thing. Okay, so what do we need to do as that operation? Suppose we can keep well, no, we'll leave it there. Yeah, so we want to fetch items from down. Can I not give it a slot? Let's try not giving it a slot. and see. It says optional. Although I'm not sure if that's valid. I want to tell it the item though, so let's go ahead and grab. Let me grab a diamond, and of course it refills so fast that yeah, it replenishes. Cool, nice. Yeah, this interface is great. This one is not going to be able to replenish. But let's tell it, hey, I want you to fill this thing with diamonds. So fetch me a diamond. Let's see, fetch me. Oh, I don't know. Yeah, no, we won't tell it the amount. We'll just say fetch me the stack of diamonds and put it in my slot 0 inventory slot. We want to tell it specifically the item, so we'll go ahead and tell it that. So we'll say fetch me diamonds from below. We're not going to tell it. We're not going to tell it what inventory slot, what interface slot it should pull them from. We're just saying, hey, go get this from there, and we'll see if that works. Who knows? And it should put that in the 0 inventory slot. And then all we need to do is then push up to the slot represented by the variable, right? So this will probably not fill everything because it probably won't be. Because this interface might not replenish things fast enough. If you pull the stack out, push it in there, pull the stack out, push it in, etc. That might not do it, but we'll find out. We can take those out. Actually, yeah, let's empty this. And yeah, this loop can actually be fairly short. So yeah, happy path is there. So pull stuff from below, pull diamonds from below, put them in our slot 0. And then this, all we're gonna say is, hey, from our own, toward upward. From our own slot 0. And then we're telling it the slot that we want to push to. And this is going to be whatever's in variable 0, so the thing that we're looping over. And the amount, optional, we're just going to leave that alone so it should push the whole stack. And then tell it, go ahead and continue in on your loop. So, in theory, this should try and fill that second row with diamonds. Let's see if it does. So it's going to take a minute because it's looping through trying to check all these things. And this process that we have in there is kind of slow. But there we go. It put in one set of diamonds. And, well, okay, it says done. I don't know. Oh, now it says done. Okay, so it only put in that one stack, and I'm not entirely sure why that is. Also of note is that we can inspect the variable here, and right now it has 18 in that slot, and it seems to be kind of perpetually saying that it's done. So I don't know. We tell this to store this in here, so I'm not sure. The program must not be ending, or in some way is just not. I don't know. I suppose we could just say, hey, store that again. Paste this like here, and then say done, just as an end to our program, just to fix that particular issue. Okay, it said done, and okay, it filled it. Cool. Okay. But yeah, it is trying to fill itself with diamonds, and that's going to be an issue. So we only want it to do this if that slot is can be filled. If the slot is not full. So that's another condition we need to add to our loop. We don't want it to try and grab diamonds if it's not going to be able to push them. So we're just going to put a wire here. Actually, I need to expand this out a little bit. Which is okay. So we need to check. Yeah, so we need to count items external, and that is our first step here. So we need to look at the inventory above us, and we want to look at the slot that we're looping over, and we don't care about the item. We just want the count of things. We want to say, how many things do you have in this particular slot? And if the answer is less than 64, then we need to, yeah, okay, if we're going to do this right, let's do this right. If the answer is less than 64, we need to subtract. Yeah, so we need to do the math about it. Actually, we should just be able to subtract it, and then we don't even need an if-else condition. Okay, so we grab this number, we're going to subtract. So the first value is going to be 64, and then we're going to subtract the number of items that are already in there. So yeah, the last number that was gotten. Then we want to fetch. Yeah, actually, this shouldn't be too much messier. Okay, happy path there, And the only thing we need to do is when we're telling them the amount that we're pulling in, it should be that last int. Actually, yeah, that's fine. And then we can just push whatever we happen to push in. I was worrying that we would need to save that number somewhere so that this pusher can know too, but it doesn't care because we should already be limited, so we're good. So a lot of the time, this is going to say 0, and so we're going to pull 0 items, and then we're going to push 0 items, and that's fine. We don't care. That's still it takes a couple more operations, but we don't. That's fine. That works for me. And now the really nice thing is that the rest of this should be fairly straightforward. So we can control-click to copy these, and we can mostly just copy these as far as I know. Let's paste them down here. And then we have, our little eval number thing to set things at the end. It's weird to me that this is not managing to work, but because it should start things off just fine. But whatever. I guess let's copy these wires as well, which we don't technically. I mean, we could technically just let things be shifted, but that's fine. I think this is cleaner anyway. So this first step is getting anything in that top row out. Then we've got things. We'll fill this thing with diamonds, which is great. Then the last step is the same thing. The only stuff that we need to change are the numbers that we're dealing with. So starting value needs to be 18. It should be 19, right? This could be an off by 1 error in the making. That's fine. I'm gonna test if it's greater than. Sorry, no. Starting at 19 and then greater than 27. I think. And then same thing, just dealing with the loops, dealing with the subtract, except here we don't, here we don't need to do the math at all. There's no reason to do it because these don't stack, so we don't need to count anything at all. So we can actually get rid of this. We'll just drag these off, and we'll make this loop nice and simple. We just need to tell it, so the amount we can just get rid of. And then slot out, same thing. We just need to change the item. Is this caring about the item? No, it does not. Okay, so let's grab then the anti-rad, and we'll just tell this, hey, you need to put anti-rads in this slot. And I think this should pretty much do it. We'll have to. We're gonna see. Let's see what bugs we. Oh, let's take this out real quick. Let's clear. Can I change this value? Yes, okay, I can. Which it shouldn't be required, but you never know. Let's go ahead and get the diamonds out of here. Just get this thing to a pristine-ish state, so that we can see how it runs. Okay, so let's put the card in, and this should spend a little bit of time looping through the top row, getting stuff out. Now it's filling up with diamonds, and now it should. Okay, no, my number was wrong. Derp. That's okay though. Yeah, so between 9 and 18, and then between 18 and 27. That's correct. Okay, fair enough. Let me gather these out of here. And actually, we should test another case of, like, let's say 32 diamonds in there. And also, we could put some junk up here saying, hey, this is junk that we don't want. Let's put the anti-rad back in the system. So, now the interface grabs it eagerly. Let's clear and put the card in. And watch. Yep, it takes everything out of that top slot. It should fill this, in theory. Let's go in a little. Nope, bad parameters. Okay, so I'm glad we tested that. Now what happens? Let's put some stuff in here just to see. It should still be running though. Yeah, okay, it extracts that. No, okay, we're still getting bad parameters. I'm not positive why that is. You know what? I bet that it is. Yeah, it is. Bad parameters is probably because we're telling it to get 0. It's probably mad about that. So, yeah, I think I'm gonna do a gross thing just because I'm tired of this already. Let's do a comparison. Let's do an equal. We'll just check for equals 0. So we'll say if the last number is equal to 0. So if there was nothing in that slot, or hang on. Yeah, no, if the last slot was equal to 64, then we're not going to do any of this, so don't even bother asking. Go ahead and just pop up to a wire, and we'll just wire back to the beginning of this loop for the next slot. So if true, then jump back and just route your way around. Otherwise, Then, now I'm going to be a terrible person. We're just going to grab that value again. We could, in theory, save it to a separate variable so that we could refer to it. But yeah, we're not going to because I'm just a bad person. Let's see here. Okay, so clear this out. So it's actually not the 32 split that it was having issues. It's the 64 diamonds. I'm pretty sure. Let's throw this in here and see what happens now. There we go. That did it. Okay. And that seems to be the fix. And it did put the anti-rad in. So that is awesome. And now if we take out this, it should eventually go about, yep, there we go. It filled it back up to 64. So cool. Now we can shift click in stuff while we are out and about that we are not going to need. And the even cooler part is that we've got this in our ender pouch. So if we're going out, we're mining ores, I go, hey, I got a bunch of cobblestone I don't want. I can just go ahead and close that up, and then it'll go ahead and remove them for me. And I can say, hey, I want I need some potatoes. I can go ahead and take them out. I can say I need anti-rad, and I can go ahead and take them out. All we need to do is make sure that we have our AE system, one, chunk loaded, but two, set up to supply these materials. So diamonds, obviously, we will change that script. We'll pump in those cooked potatoes, and then we'll get anti-rads processed as well. But cool. Now we have an on-the-go bag. And yeah, as you can see, playing with RFTools Control is interesting. It can be, a little bit interesting to wrap our head around. But yeah, it's fun all the same. And I suppose we can take out the final done instruction too. I still don't know why we need to set the number back at the very end, because this really should do it. But I don't know. Anyway, I hope you've enjoyed this kind of rambly, stumbling through episode. Ran into some challenges, but I think it is fun all the same. So let me know what your thoughts are down in the comments, and I will see you next time. Cheers!